Today we're going to be looking at learning target 6C, which is being able to solve a system of equations using the elimination method. Go ahead and set up your Cornell notes. On the left side, there are three titles that you're going to want to have. The three things we're going to be looking at is when would you use each of the three methods. We've now learned about the graphing method, the substitution method, and now the elimination method. So we're going to learn about when you would want to use each of the three. What are the steps used to solve the system using the elimination method? There's going to be 8 steps involved in that. And then we're going to look at 3 example problems using the elimination method. So the 3 methods that I mentioned that we learned about are the graphing method, the substitution method, and the elimination method. Each one has its unique time that you'd want to use it, although you can always manipulate your equations in order to fit a specific method. But generally, if the 2 equations are given to you in slope-intercept form, the graphing method is probably the easiest way to find the solution. If only one of the equations is given to you in slope-intercept form and the other one is in standard form or some other type of form, you would probably want to use the substitution method. And the elimination method is best when both equations are in standard form. For the elimination method, there are 8 steps involved in solving it. First one is you're going to want to make sure that all your variables are lined up. So as you list your 2 equations, one on top of the other, you're going to want to make sure that your x's are on top of each other, y's are on top of each other, and then any whole numbers are lined up directly on top of each other. You're going to want to get a common coefficient for one of the variables. So remember, a coefficient is that number directly in front of a variable. So you're going to want to make sure that one of them, whether it be with both x's or both y's, are the same. You're going to then either add or subtract in order to eliminate one of the variables. Just like in the previous method, the substitution method, you're then going to solve for the remaining variable. The rest of this is very similar to the substitution method. So once you've solved for a variable, you'll then substitute your solution into one of the original equations, solve for the remaining variable, write your solution as an xy ordered pair, and then check your solution by plugging those numbers back into both equations and making sure it works. So let's look at some example problems and how to solve them using the elimination method. Here's the first problem. Go ahead and write this in your notebook. Notice that step 1 is already done for us. Our x's are on top of each other, our y's are lined up on top of each other, and the whole numbers are also lined up. In most cases, if you choose the elimination method, this will be done for you, but always make sure that is done before you start doing any of the algebra involved in solving. So here is the elimination method. So we'll kind of talk through this. Notice that our x's both have a coefficient of 9. I do know that 9 minus 9 gives me 0, so I'm going to subtract here. When I subtract, that eliminates my x's. 9x minus 9x is 0, which is what one of our goals is. We have to subtract everything involved. So now we're going to subtract our y's. So 7y minus 3y gives us a positive 4y. 13 minus negative 15 gives us 28. We then need to solve for y, so I'm just going to divide both sides by 4, and I get that y is equal to 7. Once I have that solved, I'm going to take that 7, and I can plug it into either y, top equation or bottom equation. In this case, I chose the bottom equation to plug that 7 in for y. So my new equation would be 9x is equal to 3 times 7, which is equal to negative 15. And then I'm going to go through and do the algebra to solve for x. And I get that x equals negative 4. So my final solution is negative 4, 7. Let's look at another example. Again, in this case, you can see your x's are lined up, your y's are lined up, and your numbers are lined up. However, in this case, there is no common coefficient. So your x's have different numbers in front, your y's have different numbers in front. So in order for us to start this, we have to turn at least one of them into what would look like the other. So I know here if I were to multiply this by 2, I would get a 4 in front of it. So I'm going to multiply everything on top by 2 using that distributive property. So 2 times negative 2x, that's what gives me this negative 4x. 2 times negative 4y gives me negative 8y. 2 times negative 20 gives me negative 40. Make sure that when you do this, that 2 gets multiplied by each piece. I'm then just going to bring down my bottom equation so that they're lined up. And notice now my x's have a negative 4 and a 4 lined up. So I need to ask myself whether I want to add or subtract in order to eliminate. Well, since I've got a negative 4 and a positive 4, if I add them together, that will give me 0. So that means I'm going to add each of these pieces. Negative 8 plus negative 8 gives me negative 16y. Negative 40 plus 8 gives me negative 32. I'm then going to divide by negative 16, and I get that y is equal to 2. Now that I know that y is equal to 2, I can pick either equation to plug the 2 in for y. In this case, I chose the bottom equation, so I just plugged the 2 in where the y was, and I get this equation 4x minus 8 times 2 equals 8. Go through and solve for x. I get x equals 6. So my final solution is 6, 2. Let's look at a third case here. So when I look at this case, notice my x's are lined up, y's are lined up, so that first step's kind of done for us. But in this case, I can't multiply 6 by anything to get to 7, or 5 by anything to get to 6. So in this case, I have to actually manipulate both equations through multiplication in order to get a common coefficient. Now, it doesn't matter if you eliminate your x's or your y's first. In my case, I chose to go ahead and eliminate the y's. So I multiplied the entire top equation by 5 and the entire bottom equation by 6 in order to get a common coefficient here of 30. So 5 times 6 gives me 30x. 5 times 6y gives me 30y. 5 times 12 gives me 60. On the bottom, I'm multiplying everything by 6 in order to get that common coefficient. So 6 times negative 7x gives me negative 42x. 6 times 5y gives me 30y. And 6 times negative 26 gives me negative 156. So now I'm looking at these y's. They are both positive, which means I'm going to have to subtract. 30y minus 30y is what would give me the 0, which means I have to subtract everything. So 30x minus negative 42x gives me a positive 72x. As we mentioned, 30y minus 30y is 0. 60 minus negative 156 gives me 216. Then I'm going to divide by that 72 to get the x by itself, and I get that x equals 3. Once I know what x equals, I can take that x value, plug it in. In this case, I chose the top equation to plug it into. But remember, it doesn't matter. You'll get to the same answer either way. 6 times 3 equals 18 plus 6y. Go through and solve for y. And I get that y equals negative 1. So my final solution here would be 3, negative 1. As you can see, this elimination method has a lot of the same steps as the substitution method, but once you get through and get a common coefficient and add or subtract there, that step of solving for the first variable becomes a little easier. So practice this. Here are 3 practice problems for you. You can pause the video until you've had a chance to solve them. And here are those solutions. If you have any questions on this, please make sure you write them down. Come to either Mr. Dunn or myself, and we'll be more than happy to answer.